Assalamualaikum dear students, within another lecture of CIT 244 Basic Electronics 2, we will discuss the basic circuit of asynchronous type counter. In the previous lecture we discussed on the types of synchronous and asynchronous counter. In that lecture, I discussed to you about the basic definition of synchronous and asynchronous counter, where we got to know the two basic differences. That in asynchronous counter, the output state of the flip-flop counters or the counters doesn't change, does not change on applying the clock pulse. While in the synchronous counter, the output state varies or changes its position on applying the clock pulse. So, very shortly, this was the briefly description of the last lecture. Now we will discuss on asynchronous counter. Here is the definition of the asynchronous counter. It is a type of counter which does not change its output state on applying the clock pulse. On providing the clock pulse, such type of the counter does not change its state, output state. That's why it is known as the asynchronous counter. And what is the synchronous counter? Synchronous counter is totally opposite to it. The synchronous counter changes its output state on applying the clock pulse. What is the construction now? We will shortly came on the construction of the asynchronous counters. Here is flip-flop 0, flip-flop 1, flip-flop 2. 1, 2, 3. I have used over here 3 JK flip-flops. In counter we use JK flip-flops due to its very deep positions. And this type of counter is basically 3 bits counter. And I connected it with the two data input connect device 1, 2, and 3. And JK are both are connected together to this data input, and the clock pulse over here. The clock pulse is provided to the clock notching input. That is in the next from flip flop number 0 to flip flop 1. The input clock pulse is taken from the output of FF0, and similarly FF1 flip flop number 1 is providing clock pulse to flip-flop number 2 from its output. And here we take out the digital code or digital output from the next state. What is the working of the basic counter? Counter basically counts the number of pulses and give us a sequence of 0, 0, 0, 1, 0, 2, simply these things. 1, 2, 3 in decimals, but in binary coding we discuss it as 0, 0, 0, 0, 0, 1, 0, 1, 0. 0011. So similarly, this is the sequence of the binary coding counting of asynchronous counter. What happens? Now we will come to its working. When no input is applied, when there is no input on the clock pulse, what will happen? When there is no input. When we have no input on the clock pulse, what it happens? Then output will be 0, 0, 0, 0, 0, 0. And the digital code will be displayed out on the counter is 0, because there is no when there is no code, there will be nothing digital provided on due to there is no clock pulse. So that's why no output is shown. The second state, when on applying clock pulse, the output state FF0 will change from 0 to 1. This is the clock pulse sequence 0, 1, 0, 1, 0, 1, 0. When there is no clock pulse over here 0, no state change, it is 0. It is 0 over here. And when we apply the clock pulse on the flip-flop over here, the clock pulse is applied, then what happens? Then it happens that the statement of 0 of this input changes to 1, and the next two states of flip-flop 1 and flip-flop 2 does not change its position. Both remain same and display 0, 0. So the output will become 001, and we have a digital code of 1 on the output of the counter. Similarly, when we apply the third input, it will become more sophisticatedly changed to 00010 over here. Here I have the clock inputs 0 1 0 1 0 1 0. This is basically the clock pulses applied over here, and Q0 at this stage when there is no clock pulse will become 0. When we apply a clock pulse over here, then the both input states will change to 0 0, and the next data will become 0 0 1. In the third stage, when we apply the data, what happens 0 0 0 0? All the data will reset to 0 0 0 states, and we will have to reset the positions to 0 1 1. So basically, this is a three bit counter. Mostly in the lectures, mostly in the lab practice, we use 4-bit counter of asynchronous. To apply asynchronous counter, we must use 4 JK flip-flops so that we have a perfect coding of 0 to 1111. I'm hopeful that you may understand the lecture, and if you found any kind of problems, you may ask me on my WhatsApp or in the Google class. Right over here. Thank you so much. Stay safe, stay home. Happy winter season. Thank you.